So our Cmos Nor gate looks like Pmos Nor gates combined with Nmos Nor gates. Once again, just to remove the resistor from the system. So let's get into it, right? We've got a 0, 0. Remember that A is connected to A and B is connected to B. Then we've got a 0 and a 1, 0 and a 1, 1 and a 0, 1 and a 0, and all ones. So, and remember our output is always this little junction in between the NMOS or the PMOS circuits and the NMOS circuits. So now we want to ask ourselves, which ones are closed or which ones are conducting? And we know for when 0 is our input, PMOS is conducting or closed. And so that must mean that these guys are open. And so that means that 1 is able to conduct to our output. Now, if we have a 1 here, that means that this guy's going to be open. This one's still closed. So if the PMOS of B is open, that means that the NMOS of B must be closed. This guy's also open. And so here, we see that we actually have 0 able to conduct to the output. Now, we've kind of got the flipped idea here where A is a 1. So that means that the PMOS is open for A, and B has an input of a 0, so that must be closed. And so that means here A is conducting, B is insulating. So in this case, we're able to get, oops, kind of a little cockeye there. This path ground to the output, and our output is 0. And finally, if they're all ones, well, that means that both of these guys are going to be open. And that means that both of these ones will be closed or conducting. And so we've really got 2 paths that ground can get to the output, and that makes our output a 0. And this is effectively functioning as a NOR gate.